Hello, very good evening. Sorry for the delay. So, if you remember in the last class, what we have discussed the most important concept of relative velocity. Correct? The relative velocity is what we have discussed, and we have clearly seen the concept of how it changes with respect to scenarios and with respect to the values that you have seen. Say example, if we have seen we have added couple of complexities in that. We have said a person is or a train is traveling, okay, and then a person here is stationary, and we have said if the velocity of this train is vt and if the person's velocity is v, okay. Now velocity of train with respect to person or velocity of train with respect to person is nothing but velocity of train minus velocity of person, correct? This is nothing but velocity of train with respect to ground, velocity of person with respect to ground. Now if the person is at rest, so this will be 0. If the person is moving, similarly you will have a value here, and this is how you get the velocity, or to be honest with you, relative velocity of train with respect to the person. So if you see in the entire concept of physics and the motion straight line concepts, etc., there are a couple of things that you will come across, or definite questions that you can say. One is police thief problems. One is police thief. Second is rain and umbrella. And third is riverboat. And all these things, or all these three scenarios or concepts, are based upon the concept of relative velocity only. There is no difference in this. Everything is based on relative velocity. Now let's say you have a thief here, okay. You have a thief here, and let's assume he is going or he's running towards this side with a velocity of 10 meters per second, okay. Now you have the police here, okay, who's also running this side, because obviously he has to run in the direction of thief only to catch him, which is nothing but velocity is nothing but 20 meters per second, okay. Now let's say the distance between these two is nothing but 100 meters, okay. Let's say the distance between these two is nothing but 100 meters, okay. Now what are we supposed to do, or the question is, when will the police catch the thief? Question is, when will the police catch thief? Police catch your thief, or the idea is, when will your police catch thief, or when will they meet, etc. The idea is all same. If if given these questions, you are supposed to equate the times for this, okay, because that is how the entire structure is given, okay. Now tell me one thing, very simple logic or etc. Say example, if the velocity of the thief is 10 meters per second and velocity of the police is 20, you are straight away saying that velocity of police is greater than thief. That is why you are confidently saying at some point in time your police will catch the thief. Say example, if the velocity of police is also 10 meters, let's say if the velocity of police is also 10 meters, tell me, will he ever catch thief? Will he ever catch thief? No. Why? Because he is also running with 10 meters per second, thief is also running with 10 meters per second. So that means what? The distance between them will always be same. The distance between them will always be same, okay. Understood? So the first logic is, you'll have to think normally in terms of common sense point of view, wherein we are supposed to be estimating what should be the velocity, because I cannot give you a velocity of police as 20 meters per second and velocity of thief as say 30 meters per second, okay. If the velocity of thief is greater than police, in your lifetime the police will not catch the thief, correct? You understood this? So now let's say we have this thing. Now there are two ways which we can look at this, okay. There are two ways which we look at this. One is using your relative velocity concept, which is slightly easier as you've seen this. The second is standard kinematics. Say example, I have a police here. Okay, the distance between a police and thief is 100 meters. Okay, and he is running with 20 meters per second. He is running with 10 meters per second. Correct, he is running with 10 meters per second. Now what happens next is, what happens next, let's say, let's do this by two approaches. Okay, let's solve this by two approaches. Let's say let's say this fellow meets, or the police catches the thief at a point x, or at this point x. Okay, where the police catches thief. Okay, this is the point, let that be there. Okay, this is the point, let that be. Now what happens is, let's say the thief travels time t. Okay, time t at till this point. Okay, from this point to this point, let's assume the time is t. Okay, now what is the distance that the thief travels? What is the distance that the thief travels? It is nothing but, distance is nothing but 10 into time, which is nothing but 10t. Correct, which is what I'm saying. Thief from this point to this point, that is what he travels. Now similarly, what will be the distance traveled by this police? Police will travel what, let's say, in the same time, what will be the distance traveled by this police at till this point, what will be the distance? It is nothing but 20t. Correct, correct, 20t plus 100, 20t plus 100. Correct, so this is 100, and from 20t is what he travels, so the initial distance between them is 100. So that is how it is coming as 20t plus 100. Correct. Now tell me, if I am talking about the time taken, obviously these two distances match, because at this point they are meeting. So that is why my 20t minus 10t is equals to 100. Therefore my time t is 10 seconds. Correct, therefore my time takes 10 seconds. So that is how I am saying, after a time of 10 seconds is where these two people will meet. Correct, after a time of 10 seconds is where these two people will meet. Now to check how relevant is this, or how correct is this, the other way to look at is, from this point to this point, 10t, 10 into 10, the thief travels 100 meters. Correct, 100 meters. Similarly, what will the police travel? What will the police travel? It is nothing but 20t. Correct, which is nothing but 20 into 10. Correct, which is 200. So the overall distance is 200. This thief to here, it is 100, and the relative distance between them is 100. So 100 plus 100 is 200, which is what has happened. Understood? Clear? Okay, clear this concept. So now let's say, in this thing, let's say in this overall time. Now let's see one more case. Okay, let's see. I'm following the reverse case, wherein I'm saying the police is traveling with 20 meters per second, and the thief is traveling with 10 meters per second, and the distance between them is 100. Correct. Now tell me, if I'm using relative velocity concept, what is the velocity of, what is the velocity of what is the velocity of police with respect to thief? Is nothing but velocity of police minus velocity of thief. Correct, so this is with respect to ground, this is with respect to ground. This is nothing but 20 minus 10, which is 10 meters per second. So your relative velocity is 10 meters per second. And what is the distance that you have? What is the distance or relative distance? See, in last class also we have told, time, irrespective of whatever frame it is, time remains constant, time is same. Correct, and time is same, and your relative velocity or relative distance, sorry, my mistake, it is relative distance, this will also remain same. So all I have to do is find out the time, at what time will these two meet. Correct, so what I'll do is simply nothing but, displacement is nothing but velocity into time. This is 100, this is 10 into t. T is nothing but 100 by 10. 10. Understood? Clear? So it is all boiling down to the relative distance between these two people. Police, thief, thief, police, however you call it. Okay. Now there can be multiple scenarios in this. You have the police riding on a bike. I mean, thief will be riding on a bike, and then your police will be riding on a car, etc. And all. The fundamental concept is you are supposed to ensure that the velocity of police is greater than velocity of thief. Okay. Only if that happens, logically the police will catch thief. Okay, understood. Now you can have, like I've told you, multiple scenarios in this. So I can give you, say, mm, let's say one more scenario where you have police and thief. So let's say this fellow's police velocity is 20 meters per second. The distance is 200 meters between them. 200 meters, or let's say 150. 150. Okay, 150. And instead of the thief, instead of velocity, has acceleration. Let's say acceleration. Okay, now what happens again? Similarly, let's assume they meet at this point. Now thieves, because it is initial velocity is 0, the acceleration, let's say time t, it is nothing but s is equal to ut plus half at square. That's the formula I use. That's the formula I use because I know u, I know I know a, I'm supposed to find out s and t. So this is 0. So therefore s is nothing but half into 1 into t square, which is t square by 2. So this distance is half a t square. Now because this is constant velocity, what will happen? Okay, velocity into time, is nothing but the displacement traveled from for the police from this point to this point, because times remain same. Correct. Now while following the concept of relative velocity, I've told you the distance never changes. Understood? Correct. That means what? That means what? The difference is always this 150. Correct. The difference is always this 150. And similarly, while I am following the relative velocity of police with respect to thief is nothing but velocity of police minus velocity of thief. Correct. Which is 20 minus 0, because velocity of police is respect to ground, thief is with respect to ground. Correct. So that means what I'm saying is relative velocity of police with respect to thief is 20 meters per second. Similarly, what is the relative velocity of police, or sorry, relative acceleration? Because thief has acceleration. Relative acceleration of police with respect to thief is nothing but acceleration of police minus acceleration of thief. Correct? Which is nothing but 0 minus 1. So relative velocity of police with respect to thief is nothing but minus 1 meter per second. So now tell me, I have displacement, that is S, and I have V, and I have A. What am I supposed to find out? Or say, let's say U, however you call it. Okay. Now what am I supposed to find out? T, correct? So the equation that I have is S equals to UT plus half AT square. Correct? That's the equation that we have. Correct? Now this is nothing but 150 is my displacement, that is relative displacement. 150 is nothing but 20t minus t square by 2. Correct. It is nothing but t square minus 40t plus 300 equals to 0. This is your equation. Now solve this quadratic equation, you get the value of time. Okay, understood. So you can either find out using the concept of plane kinematics. You'll have to find individual people. Either you can use this using kinematics or concept of relative velocity. Correct. Relative velocity, you know that you can find out relative velocities, relative distances remain same in the same frame of reference. So that's how you are finding out the entire concept and you're dealing with it. Okay. Now you can, like I've told you, the concept remains same. What changes only is the scenarios. What changes only is the scenarios. There might be a chance where the thief takes a U-turn, the police chases him similarly, and they will ask you what is the time that the police takes to catch the thief, etc. It's all same. The concept remains same as long as your relative velocity, your relative distances concepts are Perfectly understood. Correct. So you apply similar concepts to wherever it is the same thing. Okay. Now similarly, in similar wavelength, you have the next let's say conceptual questions or next scenarios, that is your rainman problems, rain and umbrella. Okay. Rain and umbrella problems. Okay. So the idea is, let's say you're standing here. Let's say you're standing here. Okay. Now if the rain is falling, the rain is falling, the rain is showering down straightly. So what happens is, if you are at perfect zero or if you are at perfect rest, similarly what I'll do is, velocity of rain with respect to man is what I'll take, or velocity of man with respect to rain, however you want to take it. Correct. Anything. No, it is nothing but velocity of rain minus velocity of man. Correct. Velocity of rain with rain minus velocity of man. Now because the man is at rest, this is 0. Now what is velocity of rain? Understand, velocity is always vector. So what I'll say is, this is negative 40 j, because downwards, like I've told you in the previous classes, downwards is always positive, upwards, sorry, downwards is always negative and upwards is always positive. Clear? So velocity of rain with respect to man is nothing but minus 40 j. Minus 40 j. Velocity of rain with respect to man. Clear? So it is falling straight on his head with a velocity of 40 j. J is nothing but the vector cap. So if I have to replace it, or if I have to represent it in the Cartesian plane, it is nothing but I'll do this. The velocity is coming down, minus j cap, minus 40. So this is the vector, simple vector representation. Okay, understood? Now the scenario changes. The scenario changes. The scenario changes. If I'm saying, while the rain is showering down, instead, if the man is also moving with the velocity, let's say the man has a velocity of similar 40 meters per second towards right, and this is nothing but 40. Okay, 40 j. Now what will be the relative velocity of man, or relative velocity of rain with respect to man is nothing but relative velocity of rain with respect to ground minus relative velocity of man with respect to ground. Correct. Rain with respect to ground is minus 40 j. Correct. You agree on this? Minus relative velocity is minus 40 j, minus, can I simply say, if I am taking my Cartesian plane, this is I cap, this is j cap, this is minus j, this is minus a. Correct. As simple as this. So this is nothing but minus 40 I cap, minus 40 j, minus 40 I cap, sorry, minus 40 j minus 40 I is your relative velocity of rain with respect to man, minus 40 I cap minus 40 j. Okay, minus 40 I cap minus 40 j cap. Now if you're further, interested in this, simple, if you have seen in the vectors, what is this? This is nothing but, this is minus 40 I, okay, minus 40, and this is minus 40 j, minus 40 j. Correct. Now if you all remember the vectors that we have seen, there are two vectors in this. The resultant will be here, the resultant will be here, which is nothing but, because the resultant is nothing but the magnitude, which is root 40 square plus 40 square under root, which is nothing but 40 root 2. Okay, 40 root 2 is the magnitude of this, and similarly the direction we'll find out. Okay, let's assume this is theta, so this will be 40, similarly this will be 40. So tan theta is nothing but 1. So if tan theta is 1, then what is the angle? If tan theta is 1, the angle is 45 degrees. Correct. Tan theta is 1, the angle is 45 degrees. So this is 45. Okay, this is 45 degrees. It is, magnitude is 40 root 2. So you will, as a person, as a person, you will feel that the rain is hitting like this in this direction. Why? Because this is the resultant. If you see, this is the resultant. This is the resultant. Understood? Okay, let me draw it for you once again. Let me draw it for you. I am telling you that this is your x-axis and y-axis. This is minus 40. This is minus 40. Okay, j direction, I direction. Okay, minus 40 and minus 40, because you are supposed to find out the resultant of these two, which is in this direction. Now how do you find the resultant? You all know magnitude is nothing but 40 square plus 40 square under root, which is nothing but 40 root 2. Correct? Simple trigonometric formula, hypotenuse square, etc. Now this is also 40. So if this is theta, this is 40, this is 40. Correct? This is 40, this is 40. Therefore your tan theta, let me write properly. Therefore your tan theta is nothing but 40 by 40, which is 1. Therefore theta is 45. So the resultant is nothing but, it will seem, what is this? This is velocity of rain with respect to man. So the man feels that the rain is hitting him in this direction, like this. So the rain will be falling in this direction, is what he feels. It's what he feels. So that is how they will say, at what angle should the umbrella be opened so that he can avoid rain. So tell me, at what angle he should open the rain, or sorry, open the umbrella? Opposite to this. If this is 45, he has to open his umbrella at this angle, so it's just 45. Correct? So if he is opening his umbrella with respect to 45 degrees, then we can simply say that he will not get wet. 45 degrees this direction. Understood? Similar, simple relative velocity concept. All you are supposed to do is find relative velocity of rain with respect to man, which is Vr minus Vm. Put the coordinates of r and m and find it. As simple as that. Clear? Clear? Now next, let's say, let's say, let's say there is an angle of rain which is coming at say 45 degrees. Let's say this is 45. Invert the same question. Let's say this is 45 and the velocity of rain is 40 meters per second. So tell me, if the angle is 45 degrees and this is 40 meters per second, let's say this is velocity, what will be x component of this? What will be the x component? Is nothing but 40 cos theta, because this is the adjacent side. What is the y component? What is the y component? It is nothing but 40 sin theta. Correct? It is 40 cos theta and 40 sin theta. Clear? Understood? Now what is 40 cos theta? 40 cos 45. Okay, 40 cos 45, and in the I cap direction. Correct? 40 sin 45 in the negative j cap direction. Correct? So your velocity of rain is nothing but, velocity of rain with respect to the ground is nothing but 40 cos 45 I cap minus 40 sin 45 j. Clear? Now let's say there is a person here. Let's say there is a person here who's similarly traveling with previous case, like 40 meters per second. Now what is the relative velocity of rain with respect to man? What is the relative velocity of rain with respect to man? It is Vr minus Vm. Correct? Relative velocity of rain with respect to ground, relative velocity of man with respect to, correct? Which is what? Can I simply say my relative velocity of rain with respect to ground is this one only? 40 cos 45, 40 cos 45 I cap minus 40 Sine 45 j cap, correct, minus what is relative velocity of man with respect to ground? It is 40 I cap, correct, as simple as that. 40 I cap, correct. Now what is cos 45 and sin 45? 1 by root 2, correct. So this is 40 by root 2 minus 40 by root 2 g cap I cap minus 40 I cap, correct, correct. So this is your relative velocity of rain with respect to ground or man. Okay, this is your relative velocity. This is your relative velocity. Clear? Understood? Now you have 40 by root 2 minus 40 I cap minus 40 j cap. Clear? Now the magnitude of this is nothing but this square plus this square under root. Correct? Magnitude of this is this square plus this square under root. As simple as that. And similarly, tan theta. Tan theta is what you are going to get it from the relative velocity of this. Tan theta is your y component by x component. Correct? So based on this, you can find out your angle, and based on this, you can find out your magnitude also. Okay. Now once you do that, they'll tell you, because that is how the rain is falling with respect to you. That is how you perceive. That is how you perceive rain hitting you. So all you have to do is find the umbrella in the opposite direction. Correct. So if let's say if the rain is hitting like this, simple logic. If the rain is hitting like this, the same rain is hitting like this, what will you do? You will open the umbrella in the opposite direction. Correct. So that you do not get wet. And I'm saying opposite direction. This is how your umbrella opens. Correct. So the rain falls on this, and that is how you do not get drenched. So similarly, I'm saying in this scenario, if the rain is falling like this, let's say the rain is falling like this. Let's say the rain is falling like this. Correct. Now, how will you open the umbrella? How will you open the umbrella? In this direction. Clear? So, therefore, your effect of rain in this direction is nullified by the opening of umbrella in this direction. Got it? Clear? This is all that is there to your relative velocity and rain man problems. This is all that is there. They can give you a man running on the x-axis, y-axis, okay, and similarly rain falling vertically down at an angle, etc. All you have to do is resolve the components properly and then take the directions. As simple as that. Resolve the components properly and take the directions of that. Clear? Understood? Okay. So these are the maximum scenarios that you can get. Different angles, different combinations of x-axis and y-axis coming in. The rain falling at an angle, the initial one, and then a person running like this in the x direction or y direction. All you have to do is find the relative velocity of rain with respect to man. Find the relative velocity of rain with respect to man to estimate how the rain is exactly hitting. How the rain is exactly hitting. Okay, clear, understood. So with this, we will find out the concepts of relative velocity, and in the next class, we will entirely revise the whole kinematics or motion in straight line. The entire, starting from first till the end, we will revise the entire thing so that you understand which scenarios we have discussed, which concepts, and where to apply. Okay, all the concepts starting from your basic formulas, your basic integral and differentials of S, V, and A, and then finding out the instantaneous velocities, instantaneous speeds, average velocities, average speeds. Then we have seen the motion under gravity, and then we have moved to the relative velocity concepts. Clear? So we will revise all these things once again, so that you, starting from last, you understand the entire concept. You remember and you thoroughly are through all these concepts, so that any kind of question they give you, you can answer similarly in terms of the concepts. Clear? Thank you.